gesture recognition with FMCW radar and deep learning. The goal of this project was to recognize 10 different hand swipe gestures performed in front of a radar. The recognition should work for any person and be reliable, while using deep learning, with a neural network that can fit on a microcontroller. A radar sends out radio waves towards a target. These waves then get reflected off the target. The radar receives those reflections and processes them further. This project is based around the Infineon BGT60 radar chip. It works at 60 GHz with an FMCW bandwidth of 5 GHz, resulting in a distance resolution of less than 3 centimeters. There is one transmitter and 3 receiver antennas. The receiver antennas are arranged at 90-degree angles to each other. The analog signal of the radar is converted to a digital signal. A Cortex-M7 processor applies an FFT and thresholding to this signal, resulting in 3 sparse range Doppler matrices with intensity and angle information. This is then fed into a convolutional neural network, which outputs the recognized gesture as a key press to a computer, or an application, like the game 2048, can be controlled. The neural network was designed and trained in Tensorflow and later compressed into the Tensorflow Lite format. On the microcontroller, Tensorflow Lite Micro is used. It runs the compressed models with optimized layer implementations, based on the neural network part of the CMSIS library. The digital signal processing part of the CMSIS library is used for calculating FFTs. The DNN receives 30 input frames every second. Each of these frames consists of 3 sparse range Doppler maps with intensity and the horizontal and vertical angles. The range Doppler maps are evaluated at a range between 17 and 45 centimeters, while the Doppler velocity is evaluated between positive and negative 1.5 meters per second. The input frames are buffered, such that every gesture classification is based on 8 timeframes. The output has an identical data rate of 30 classifications per second. This animation shows the intensity of a range Doppler map for a left swipe gesture. The target's circular motion in the range Doppler map is equivalent to the hand approaching the radar and accelerating, then moving farther away and decelerating again. When the hand is directly in front of the radar, the velocity towards the radar is 0. This is the architecture of the used convolutional neural network. Starting with the convolutional layer on the left, this network extracts increasingly more abstract features from the range Doppler maps, combines them in the fully connected layers, and predicts the probability for each gesture. The neural network consists of 14,000 parameters and requires 22,000 floating point operations for every classification. It was trained in Tensorflow on a total of 1,400 gestures from 15 different people. The DNN outputs 10 probabilities. 1 for each gesture, plus an additional 1 for the idle state. After first tests showed promising results, the radar was placed in a showcase for demonstration purposes. Due to the changes, the neural network had to be fine-tuned for the new environment. Using another 200 gestures from a single person, the fully connected layers of the neural network were retrained. The distance to the front panel is chosen, such that the radar can capture most of the motion of every gesture. The red lines offer a guide to the users, making the gestures more consistent. There are different programs to demonstrate this project. In this demo, the type of performed gesture is displayed on the screen. A more exciting demo is the game 2048. The goal is to create a block with the number 2048 by moving blocks left, right, up, or down. Since the diagonals are not used, they are mapped to the most likely adjacent gesture. Moving the fist towards the radar acts as the Enter key, enabling menu navigation.